Good evening, everyone, especially Navinya. So today we'll be discussing about the drafting of this product, right? So as we discussed that designing a product uh, is fine, but it's also most required to have a proper documentation of the same. So currently, as we have designed our product of the portable home battery, now we will see how we can document it properly. So using the documentation, anyone can recommend your design as well as can design it easily. So to do that, there is an option as drawing. So from drawing will be from our design. So we click on that. So this is our current design that has been in the contents full assembly, right? So there are many types we can do. So currently we will do for full assembly, create new, okay, and we will do it from scratch, right? Standard, ISO, and there is also an option for ASME. So right now we'll be going for ISO, that is the international standard. So units is also mm. So keep in mind to use mm almost for any kind of designs, even if it's a vehicle design. The reason is that mm is most considered for any drafting. And seat size, you can do anything. That depends on where you are working right now. So let it be A3 for now, and we will click on OK. So once we do, a page will load of the drafting sheet. It will take some time. Okay. So once it loads, here your product is there. So right now, this is a small image of the product. Here you can have the options to scale them. 1:5. We will top it down to 1:4. And see the model has become bigger now, right? So this is the scaling you do. If we do 1:2, see how big the model is now. So conveniently, let's go for 1:3, which is much more a prospective view of the model. There's other options as well. You can orient it to any isometric view, front, top, right, home, any view that you want. So right now we will go for the front view. Okay. Appearances, there are multiple options. So this is the first option, right? So there is option for this one as well. So we will see what are the options are there. So right now let's put it down in the drafting sheet. You can click and drag it anywhere, and let's click on OK. See, this is the image has been generated where there is no intersection lines which are behind it. So only the front image and front line of sketches are being drawn here. To implement the behind hidden lines as well, see if we click on the second one, the hidden edges and lines also come up to be visible here. If we do the solid modeling, here a shaded image of your product comes up with the appearance that you applied for your product. If we go for again hidden one, see, this is the product image it comes. So for an ideal drafting, we always go for the visible and hidden edges. Right now, there is options for tangent edges. For example, you have a lots and lots of curves in your figure. Okay, so in that case, we go for full length for a detailed design, and we will keep it as off for a normal system level drafting, right? So in this case, let's keep it on medium. See, there is a detailed line and curves are being generated here, which was not previously. So let's also keep for interference edges. So what are interference edges? For example, two faces or two bodies are intersecting inside a body. Those lines are kept hidden. So once we keep it on, those comes also as visible. So let's close it. So this is your current product front view, right? So how to do the drafting in this case? So a few things that you need to follow up are that whenever you're drafting, the dimensions you're taking, always the smaller dimensions are in the front, the bigger dimensions are at the back. Okay, so from smaller to bigger, we'll uh, put the dimensions. So there are options for dimensions here. We will click on that. So if you click on this line, for example, our very top line, and we click on the very downward line. See, this is our height, and we are clipping it as. So height is 475.9 mm. right? Which is in the sense around 47.6 centimeter. So similarly, this is our top part. So we will identify it as well, and it's around 109.24 mm. Cut. So there are two types of drafting we need to take care of. One is a system level drafting, another is a detailed level drafting. In system level drafting, we use it to give a proper view and proper dimensions of the body, which only can give you a perspective view that how much big, what is the volume, what is the dimension of the body. And this is only required when you're pitching it to anyone, you are trying to visualize the product. Okay, so when you're doing it for maybe design part, maybe doing it for a analysis part, in that case we go for a detailed design. So right now this is a system level design. Okay, and once you're done with that, we will also show you how to do a detail level design. So right now let's select this one. Okay. So our three body parts are being labeled here. So one is the top part, one is the middle part, and another is the bottom. Now we will do the same as for our charger here. So here there are many things you need to explore, but we will try to cover up the list here. You can also drag these ones like this. Okay, so right now we'll keep it as it is. Next, we will go for the base. So this sign indicates it is the diameter. Okay, if there is an option R, then it implies that it is a radius. See, insert symbol. So there are multiple symbols you can see. Currently, this symbol represents that it is the diameter of the base. As it is a circular, we can see the diameter. It's 200 mm in length as well, you can consider. Okay. So this is current our basic perspective like system level drafting. That's quite easy, and it's the only needed for like pitching purpose when you're trying to show someone about your product dimensions. So this is the things, the specifications you can call it as well, which are being showed when you're pitching your product or kind of displaying your product. Also, if you see, there is an option for base view or auxiliary view or projected view. Let's go for projected view. See, you can project it like this. Okay. So these are the isometric views. This is the side view. This is the top bottom view. This is the top view. Okay. So this is also you can generate the views of the product. Let's select for like the isometric view. Okay. Once you have clicked it, you have to tick it. Now this you have to drag it down here like this. So for system level design, what we do is that we try to keep the dimensions in one end, which means the dimensions here. So that if we keep the product here, the dimensions should come in the middle portion. So from left to right, from right to left. So in this case, you can see it got all the hidden edges being shown here. See, this is the battery you can as well see inside, right? Similarly, here the charger ports you can see inside. So right now in this case, what we will do is we will try to hide them to give it a better look. So here you can do it. See, only you can see the visible edges. So this is not required for like in system level design, only this much is required, right? Because you're not designing it from inside. So you can give the dimensions like the radius of this part or this part, right? So this is isometric view. For isometric view, mainly we do not give dimensions. We only give dimensions the front, back, bottom, and side views. So this is, for example, is enough for our system level design, which is being used for pitching purpose. You can add another sheet here and let's do the detailed design right now. So for that, go for base view here, click on base view. So you get a basic view of the product. So let's go for 1:3 as it was our view here. Click on this one. So as we are giving different types of view, we'll try to keep it consistent and like filled inside the form. So we'll click on this one. We will do the visible and hidden edges as well, and we will shorten it out, which will show the interference edges. And okay, our model has been generated. Similar way, first the step is that you project all the views of the same. It helps you to give the minimal dimensions required for the design. Okay, see, the design has been created. Again, go for projected view, click on this one. We will go for the side view. You can go for any side view because ultimately side views are the same. We'll keep it a bit away like this. Okay. And another is the top view, right? We'll go for that. Sorry, bottom view for that one. Right now, you can see I cannot drag it on the sidewise. So to do that, there is an option. You click on this one. Okay. So you click on the center and sorry. Wait 1 minute. There is an option where it is rotate, right? So our tangential rotation will be on this direction. I don't know why it's not working right now. But what you need to do is that once you are going for rotate option, you click on this one in the any on transition position. You change the path of the movement, right? So if you change the path on the movement rightly, this movement will go this way. If you do it like this, it will go this way. Okay. So I don't know why it's not working right now. As well as you can see both were identical, right? So we do not need both of the views. Only one view is enough. So detailed design requires all of the detailed part designs of the product. So to do that, click on dimensions. So we will do the same again. Go for the bigger parts and we will try to give it as far as away from the body. And step by step, we will go for the smaller dimensions. So this helps you to gives a better view that step by step we are doing the dimensions. Right now we have did the dimensions for this part. So we have to do for this part, right? Now again, these are squares, circles, right? So we have to give them a radius. So once you keep your mouse at the surface edges in the arc, you will see the diameter has been provided. Click on that and like this. Again, there is an inner diameters as well. So we will do that as well. Another. Sorry, yes, this one. So I missed one. So 20 should be at the first and 18 should be at the third. Sorry, 20 should be at the second, 18 should be at the third. So first, second, third. So done this part. Similarly, we have to do for this as well. Done. See, this and this are same, identical, and this as well. So everyone knows that. So how to do that? So you are not going to mark each and every circle of these three independently. So there is an option you can do. So to do that, you go to text. Okay. So we will keep the text here. For example, we will put as 3, which means there are 3 circles of the same identical dimensions. Now we can rotate it like this. You can rotate it like this. Okay. So into 3, which means there are 3 circles consecutively with the same 5 diameter. Okay. So we have this as well. See, these are also identically same. So what we will do is that we will dimension only one of the circles like this, and we will again use the same text option. So you can copy this one, right? See, you can copy this one and you can put it here. See, like this. So that helps you more. Again, going for text and clicking it multiple times, and it is how many? 1, 2, 3, 4. So you go for 4. Close. Now we can rotate this one. Right. So there are 8 diameter, 4 circles. Again, you should not miss this one. So there is another dimension that we need to give. Again, see, these both are identical, right? So we will go for any one of them only. This is 4. And you can see if we put it like this, done. Again, there is another, this dimension. Need to give it as 8. Done. So once it is there, you know there are 2 more like that. So again, we have this one. Now there is an arc right here. We have to do that as well. Okay, we will click on the arc and see there is a radius already being marked here. We'll keep it like this. Same goes for here, below one. Right. So this is a detailed dimensioning. Now, right now we have done for this side. Now we have to go for the base as well. So let's mark for the base. There is an arc here, C. So we have to mark that arc as well. Okay, done. We have to do this one as well. C. 9. So you have to see what are the dimensions required for designing this. So there is no mistakes while designing the perfect dimensions. Again, see, there is a curve here. So we have to see how much radius the curve is made of. So there is 90 radius. We have to rotate it like this. There is a 30 inside and outside 90. So we'll also go for this one. We will mark it as 90. Okay. So these are the, if we see, for example, a few of the dimensions you can mark on the left as well, but it is recommended that most of the dimensions, if visually proper, then mark them on always the right or either left, any one side. Okay. So we are currently done with this part, and we will go for the second one as well. So this is a side view, right? So in case of side view, there are a few dimensions we still need to take care of. For example, this one. So you have to think on yourself that what are the dimensions required which successfully can help me to design the same model. Okay? So there is no, what can I say, complete uh, guidebook on how to do the drafting and all. It all depends on the person who is drafting it, because the more the drafting is easier to look and appealing, the more the another person can design it easily. So we are done with this. This arc is already being given here, so there is no need of this one. So the base is also has been mentioned here, so we'll not be doing this. those are the things that are required to do the side view. We will only go for those ones. So see, there are nothing else much to locate here because all of them are done in the front. The basic carving, the basic side view, and the what can I say? These dimensions are very required. So we have given them all. Now we'll go for the circle. So there are two circles you can see. One is the top, one is the bottom. So you have to identify as this is a top view. So the top sketches will be visible, whereas the bottom sketches will be in dotted lines. So see, the top sketches are visible. This one is visible, but the other dotted lines are bottom sketches. So we will mark them all. So we will go for the highest one first and we will keep it at the farthest away. Then second. So see, once you have designed it was easy process. But when you are going for a drafting, it looks so much more complex. Accordingly, you can do this one. So see, this is the basic part. Now there is also battery, right? So battery, you have to do in a different way. So to do that, we will go back to the home battery. We have to see only the battery is visible, not the whole body, right? So do that, we will hide the main body, bottom, the top, the charger. Okay, so we have only the battery being visible right now. We will save this as well. So once you have saved and now only the battery is visible, we'll go back to our design. We will open another sheet. We will go to our, we will have to click this one. We will go to our base view. Sorry, my, yeah, it got hanged a bit. Give me a minute. Okay, so base view, click on model, create new. Okay, so I guess you cannot do in the same draft. You have to go for another draft. Okay, so you can save this one right now. So our draft has been saved. So if we go back to our model, we go to design, and only the visible only, right? So our whole assembly is not now. So we are not going for the whole assembly. If we click for full assembly, the whole body will be there. So right now we'll be selecting only visible only, and we can click OK. See, our model has generated here. We will keep the same scale and open the interference, visible edges, you shorten it, and OK. See, so this is our current battery view. So system level design is easy. You can do the same way as we have did for the main body. So we will see the side views. We will see the top view, and this much is all required because top and bottom views are as the same. So in the same way, you have to go for dimensions. Now we will do it in a fast way. You have to click the side views. We will go again for the inner dimensions like this one. Those are the, you have to decide it on your own based on what are needed and what are not. We have done. Again, this one, and this one. Similarly, top, bottoms. This and this are same. Okay. So you can, what you can do is that you can directly put the text as cross to after this one, right? You can just drag it a bit right here, and you can put a cross to here in the text box. Again, we will put a whole dimension. You can click the corners if you cannot click the whole edge. Okay, so like this we can do. Again, there is a curves here. We have to consider them as well, whereas these dimensions as well. So this is 150 right here, and This is 738.4 in here, right? So smaller to bigger, we have to keep the pattern in. So these circles again 75, sorry 5, and you have to put as cross to here. This we have already been given in the first diagram, so we no need to do that. And here, see, we have already mentioned the 29.8 as the diameter of this arc. So we can use that same to build arc. So no need to put another radius or another arc measurement here. So we will try to keep it more minimal dimensions as possible to do the design. See, we have to do the thickness as well, right? So here we can do the thickness. Done. Again, we will not clumsy it up, so we will try to put the smaller dimensions up here. Again, you can put a cross to replicate the same for this one, right? The heights are same, so no need to mention the heights as well again. So we'll go for this inner dimensions. See, you can now see there is a problem. We cannot click on these points. So even you can do one thing. You can click on this line and click on this line. Right. Let's see. Like this, you can do it. So there is a problem. It is showing. So we will resource it. Sometimes it may become a bit nerve wracking as well. So I don't know what it's showing. I will take a look at it later. So 28. See, all are same. So you can do what is 28 cross 6. 60. Bottom is 60 as well. We go for this one. We go for this one. Right. And again this diameter. Okay. So here done right. So here this one as well. So like this, you have to do it on your own. And this was drafting. So this was the detail, and another was the system level design. So next step, what you have to do once you are done with both of them, you have to click on base view. You have to bring it in. Front view, everything is okay. You have to go for a shaded design. We will go for full length and interference edges. Done. So this is mainly a draft which shows currently like with all the texture, all the uh, 1:3, sorry, all the texture, all the appearance and physical material once the drafting is being completed. So this is also required because you're applying the textures, right? So the one person who want to do the same design, they need to have all the textures being mapped properly. So like this, in the isometric. So once done, we will drag it here. So like this. So this is your final design that you have to keep the final drafting where the person who's now ready to apply the physical materials and uh, the texture and appearances, they can do it from here. We will save it and we will close it. So now finally you can see all the things that were required for a person do the same design is almost done, but still a point is remaining here. So that is the physical material and the volume, weight, mass of inertia, the current XYZ components of inertia, IXX, IYY, IZZ. These are the things that you require for your further research work. To do that, you have to click on, sorry, I opened it. So to do that, you have to click on properties. There is an option here. So click on properties. It will generate. It will take maybe a few seconds here. See, now we have the material as varies because all types of material you have used here. Go to physical and you will find all the details of you. The mass is currently, the volume, the density, the area. See, these values may vary based on your calculation and based on what you've assigned here. But when you're doing a detailed modeling, uh, that will require like all the details to be proper. So right now it may not be proper, but when you're doing for research works, it should be proper. So here is the mass, the center of mass, the bounding box, like under how much volume it is total. So if we curve it into a small box, so what will be the length, width, and height, which is required when you're doing a 3D printing. So moment of inertia, we have noted them down again here. So these are the things. If you want to see it part by part, you have to click on bodies, go to main. Okay, first let's cross it down, go to main. For the main body, it has been generated, physical. Similarly, if we cross it and go for only the battery, for the battery, it will be generated. So this you can do like that, and you can copy the whole properties. Okay, for example, you want to copy the whole properties. So to do that, once it's been generated, there is an option copy properties to clipboard. So once done, you copy it down to your notepad or maybe your Word file. So that will cover up your product design, right? So I guess yesterday we have kept for rendering, right? So let's see how the product rendering has come up. So see, we have closed the product, but still it is rendered in the cloud. So it will not hamper what you're doing currently right now. See, this was the product that we have rendered in this case. Okay, so you can do it like this. And yeah, this was enough for today's class. And I think this will cover up almost what is required for a product designing at the beginner level. And if you feel that there are any things required further to finish up your model, you can always text us back in our group as well as the WhatsApp group. And here for today, we are ending our portable home battery design. And out of this, if you cover up all of the steps till now from day one, you will get a fantastic product design, as I can guarantee, and a good product project to produce in your resume as well. So thank you for joining the session today.